Alright, how's everyone today? Well, not everyone, but how are all of you today? It looks like something might finally get done. 1998, cool. Yeah, there's no good internet access. I do DSL for a while, and it's slow and it's expensive, and then I switched to cable, and that works for a while, and then switch back to something else, and it's it's a moving target. Oh yeah, the tap. There you go. Yeah, DSL is kind of a little slow unless you can get fiber, and yeah, phone companies just always behind the curve, it seems. Um, I moved into a house back in Virginia years ago and got cable service turned on. I wasn't getting a signal, and I called the technician, and he came out, and we walked up the hill, and well, somebody had taken a lawnmower to the grass, and the cable was in, about 100 pieces, each about an inch long, all the way up the hill, going up to the box. So yeah, that was the problem there. I don't know who has fiber. Um, I've considered it, but I also do all these uploads for class, and so I gotta worry about upload caps. Oh, that's nice. Yeah, dedicated line would be pretty cool. Um, I lived in Salt Lake City for a while I was doing consulting work for a finance company in San Francisco, and they were paying for a 128K dedicated line. Well, not dedicated, but 128K line, which at the time was pretty good. Yeah, I can tell you stories about modems, but that's a story for another time. I just threw in my own secondary firewall though, because out of the blue, my cable modem, which was also what I was using for my router, suddenly reset to factory default, right? Which I recognized because my hardwired IP addresses didn't work anymore. But that means that for a while, my whole intranet was sitting out there with like default username and password access, which is kind of a. So I threw a second router in between the router that the cable company gives me and my actual intranet. So I've got control over that. Yeah, it was a little spooky. Um, hey, dial-up's an option. Yeah, static IP. So I had a business line through CenturyLink, I think it was, so that I could have a static IP. And at some point, I didn't need that anymore, and so I called them up to cancel. And they asked why, and I told them didn't need this anymore. And they're like, well, you can go back to like basic service. And I'm like, yeah, but this anyway. Long story short, turned out that for like $20 a month, I could get the exact same deal that I had, but higher speed. I could keep the static IP, all this other stuff, right? Just because they didn't want to lose me. So I think I switched off just because that was annoying. All right, well, so that's our griping about internet service provider part of the show. Um, any questions or other comments? 5 to 10 minutes. Wow, that could be a security feature. The ever-changing IP address. Okay, hopefully people are making good progress with PA1. So reminder, tomorrow is an open lab, so I won't be lecturing on new material, but you can come by and work on code, ask questions, things like that during class time. If you don't need or want to do any of that, don't have to come to class. You can take it as a free day. Um, Security does always come at the cost of convenience. Yeah, I guess that's true. All right. Well, let's talk about generics. So we put together a linked list class yesterday by hand, and we wrote the code to make a linked list of integers, simplified linked list, just inserting at the front. And then we ran that, and it worked fine. And then we said, what if we wanted a linked list of strings? And it turned out we had to change very little in the code. There were a few spots where we said int, that we changed to string, and it continued to work. And then a linked list of rectangles, we went through in those same spots, we changed the word string to rectangle, and we had a linked list of rectangles. Okay, so this is a common theme. If you design a class and it works well, and it's been designed well, right? It will often be general purpose, and it can be reused in other contexts. And this is the idea of code reuse, right? Not having to constantly reinvent everything from the ground up. So, wow, look at all this stuff that's just like left over here. So a linked list, for example, is a class that's available to us. It's defined as a generic. Okay, so what is a generic? A generic means that the same set of code can be used with different types of objects. And so in this case, we can have a linked list of whatever kind of object we want. And when we construct the list and when we declare something to be an object of type linked list, we have to tell it what kinds of things are in this list. Okay, so that's what this placeholder E is in the description of a linked list. And when we make a linked list, we can say, you know, linked list angle bracket string or angle bracket rectangle, and it will make a linked list of that kind of object. And this placeholder, which is usually called E in this documentation, right? That's the type of elements held in this collection. And if we have to specify an argument of that type, right, it will show up in the description as an E. So for example, the add method adds an element to the end of the list. Well, the argument to that is the element E you want to add, which is an object of type, you know, uppercase E, whether that's a string or an int or whatever. And so let's use this. Let's see. Quick question on homework on the GCD. How do you handle if the numerator is bigger than the denominator and denominator is bigger than the numerator when you get a chance? Let's see. So Euclid's algorithm, right? If you have something like you know, 240 over 28, right? That's okay. No, there's really no interruptions in this because it's all related. If you have something like 240 over 28, right? The usual algorithm that we talk about is, you know, take 240, express it as something times 28 plus something. So in this case, it's going to be 8 times 28 plus 16. And then bring these down. 28 equals 1 times 16 plus 12. And then bring these down. 16 equals 1 times 12 plus 4. And then 12 equals 3 times 4 plus 0. When you get to a 0, that's your GCD. Right? And so this algorithm, as we write it, usually assumes this number is bigger than that number. But if you happen to do this where the numerator is smaller, depending on how you write your code, it usually just works automatically. So for example, if you started off with 28 equals something times 240 plus something, right? The integer value when you divide will be 0, and the remainder will be 28. And so the next problem you'll solve will be basically the GCD of 240 and 28, so you're back to your original problem. So this is a good one to code recursively, and basically GCD of A comma B is the same thing as the GCD of B comma A modulo B. Right, so the remainder when you divide A by B. And so if A starts off smaller, the GCD of A comma B will end up just calling the GCD of B comma A, and it'll keep going. And you stop this when the remainder is equal to 0, and in that case B is your GCD. So yeah, it's a cool little recursive function if you code it like that. Something about not using packages in a previous class. Can I use math.abs? Yes, you can use the math package. What I don't want you to do is define your own package for this stuff. So don't make a fraction package, you know, or a 223 package or something like that. Because I want to be able to get to your class by just saying fraction without having to put in a preamble or an import or something. But yeah, you're free to use the math.abs method. And double.nan and all that other stuff. All right, so linked lists. We can construct a linked list of any type that we want. Let's make a linked list of strings and see what we get to from that. So So I want to make a linked list, my list equals new linked list. Alright, now because linked list is a generic, we need to tell it what kind of objects we're going to put in this list. And we only really have to do it in two spots, when we declare the object and when we construct the object. I'm doing them both in one line, so this will be all on one line. So my type of object is going to be a string. And I'll specify it there on the constructor. Once we've done that, my list is a linked list of strings. I don't have to keep saying string, 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 right? It's now part of what a linked list is. It knows that's the type of thing being held in it. Alright, so there's 4 random strings that I'm going to add into my list using the add method. Alright, once we've done that, we can do a variety of things. So for example, we can find out how many things are in our list because there's a size method. Returns a number of elements in this list. Alright, so we can call the size method of my list and print that out, right? And it should return 4. Alright, so first detail is when we try to compile, we're going to get an error, right? Well, we're going to get errors because they have typos. So we got to fix those. Okay, second issue is when we try to compile, we're going to get a different kind of error, which is this linked list is undefined, right? It doesn't know what a linked list is. It's not part of Java that we get sort of automatically for free every time we write a Java program. Just like printf is not a part of C, right? It's a runtime function that you can call, but linked list is not, right? So where do we get linked list from? Well, in the beginning of the documentation, you'll see this description of it: java.utility.linkedList. Okay, so there are packages that are basically collections of classes, and there's a lot of packages. There's a lot of classes. It would be unwieldy to have all of those things sitting in our namespace, right? So that if we said linked list, it knew exactly what to get. And there's ambiguities from one package to another. So if we want to use, in this case, a linked list, we have to say java.utility.linkedList. Okay, and that's not terribly convenient. So what we can do is instead we can say, let's use java.utility.linkedList, or java.utility.star if we wanted multiple things from there. And then when we're looking for a class, if it's not, in our current directory, or one of the things that Java knows about, like strings, it will look in these packages that we've imported. So so we can do the following. We can say import. And once we've done that, when we try to compile, it should be able to find linked list, and that works great. Yeah, I don't think there's a GCD method built into math, but I mentioned that just because someone always finds something that does something I'm hoping people will write. So I figured I'd just be proactive and say don't use a built-in GCD function. I think people have done that with primes. All right, so we can run this, and it tells me my list size is 4. So not a big surprise, but we added 4 things to our list, and there you go. Yeah, so if you say star, it's going to, I don't think your output will end up being larger, but I think it will slow things down, because now you've basically said, anything from java.utility might be included in here. So if I put in something that's not found, it's going to search through, a larger namespace. And if we go to kind of, the overview of the documentation here, slow the compiler. I don't think it'll change the execution because I don't think it gets linked in automatically. But if we go to the overview page, you can see the packages that are available, right, with standard Java. So AWT is for doing drawing stuff, the abstract windowing tool set. And there's a sub-package in there just for managing colors and data transfers and events and so on and so forth. And there's a package for doing input and output. There's the language package, which is sort of the core of Java. There's a bunch of stuff under math, and way down here there's this utility package, and there's some specific utilities listed. And if we look at the java.utility, you can see things that are contained in there. So there's interfaces. We'll talk about interfaces later in the quarter. And there's classes. And among these classes is something called a linked list. That's the one we're working with. Yeah, we're gonna blow through input output in like one afternoon. But yeah. My architecture teacher had a slide where he said, it said, and input needs to be considered too, because input output is usually like the footnote when people or used to be when people were designing computers or building languages or operating systems or things like that. It's like, oh yeah, we got to do the input output system too. And so it always ended up being a bottleneck because it was everyone was CPU focused, but you really got to kind of do them together. As a friend of mine said, if you build a beast, you got to feed the beast. So fast CPU needs a really fast I/O channel to get data in and take data away. Otherwise, the fast CPU doesn't do you any good. Let's see. With so many libraries, some doing the same thing, is there a way to know which is the best for the same functionality? It's a really good question, and I think that comes with experience, and it comes with specifics of what you're trying to do. And I'm not an expert in Java, right? I would never claim to be, even though I've been doing Java for well over a decade. I know a kernel of Java that works for me, but for example, the I/O subsystem. There's writers, there's buffered writers, there's stream writers, there's print writers, and there's all these different ways to do things, and in some sense, it just keeps growing. A new need develops, and a new package is created, or more things are added to an existing package. My suggestion, particularly at this point of things, though, is find a path to what you need, and learn that and use that. And if it's not the best solution, eventually you'll discover that. If you're using a raw reader and you're constantly parsing integers yourself and putting them together, that's going to force you to eventually discover something like a scanner, right, which will do input parsing for you. Or if you use the string class to make strings and you're chopping your strings up by hand like we would do in BASIC, eventually you're going to spend some time, look through the documentation, find the split function. And, if that's something you need, you'll start using it, and it'll become a big, top shelf item in your tool chest. So I would say, let it develop kind of organically, and in an on-demand way. Imagine using a basic input-output system when you can use advanced input-output system. All computers from this point forward should advertise themselves as having an BIOS, and so yeah. It's funny, we still talk about BIOSes, and you still get them when you boot up your machine. All right, so let's see what else we can do with linked lists. So we can see how many things are in there. That's the size method, right? Now, when we build a linked list by hand, we have usually a sentinel node, and we've got a data field and a pointer field, and we move through the list by following the sentinel's next field to go to the first node and follow that thing's next until we get to a null and so on. And none of that is exposed to us in Java when we work with a linked list object, right? That stuff is going on under the hood somewhere in some form, but we don't deal with that, right? Our whole interaction with a linked list object is going to be through this set of methods. And so, for example, if I want to add something to the list, I call the add method. But this lets me not worry about writing this low-level code, right? So we get to use this code, and we don't know what happens underneath, but we don't need to know what happens underneath. We don't need to worry about it. We don't need to deal with it. And, we're told in the beginning preamble of this that this is a doubly linked list, so presumably there are nodes with pointers pointing forward and backwards, and so they're efficient and so on and so forth. But we can treat this linked list as, a simple linked list. We can treat it as a queue or a stack that we just keep adding or removing from one end or the other. We can also treat it like an array because there's a get method, which takes an integer index and returns the element at that index position. But unlike a traditional array, if I delete something from the middle, right, all my indexes move down, I don't have to spend the CPU cycles moving everything down in memory, right? Since this is a list underneath, it's just going to remove that node and re-index accordingly. So if I want to look at the data in my list, I can just do it with a good old for loop. So my list, and I'll use the get method. So I can iterate through the elements in my list myself by just, treating it like an array basically. And instead of saying, my list bracket I have to use the get method, but I pass it an index of I. And that should let me look at all my elements. So there you go. And so the add method, which I was using here, says add the specified element to the end of the list. So the first element that I add is the first thing in the list. The last element that I add is the last element. So when I print this out from first to last, these elements are coming out in the same order that I inserted them. So it's something like a FIFO, right, in some sense. If I wanted a different behavior, I could say add first, which inserts the specified element at the beginning of the list. That's going to give me a LIFO. That's going to put each new element at the beginning. So by calling add first, right, now I've got a list where my elements are reversed. And how much work did I have to do that? Almost nothing. I just called a different method. And this is the power of objects. This is my Darth Vader moment. This is the power of objects, right? We think of my list as a variable, but it's more than that, right? It's not just a linked list with a bunch of data in it. We can think of this one object, this one variable, as also having inside itself all of this stuff, all this code. Which means as long as we've got, just one object of this type, we can call, whatever methods we want as part of that object. Now it's efficient, right? It's not like this object actually sits in memory and has all this code sitting inside it and it takes a billion bytes, right? Everything is referenced. But the effect is we can think of it as just, here's a thing that has, maybe some fields associated with it, but also some code. And so this is what you're doing with your fractions, right? When you say fraction a equals new fraction 1 comma 2, a is a fraction, but it also has, a multiply method and a divide method and a toString method and all these other methods. And you can just kind of think of it as being a piece of that object. Okay, so that's where you're in the object-oriented mindset. Well, one thing that's always fun to do is when you have an object, try printing it out. So let's just print out the value of this object, myList, and I'm going to print it by concatenating it with a string, which we'll call the toString method in this object, and print that out next to myList. Now if I look for a toString method, I'm not going to see one. Right? There's no toString defined as part of a linked list, but there is a toString defined in this thing called an abstract collection. And because of that, there's a toString method inside anything that's extended from an abstract collection, including a linked list, because it's an abstract collection. So this should do something. And in fact, it does something really nice. It prints out the contents of my list from first to last inside square brackets separated by commas. So maybe that's what we want to do when we want to convert our list to a string. If that's what we want, we can just call the toString method. If we want to do something different, right, we can go through the list in our own way and put this together in whatever format we want. Print each element inside angle brackets and put colons between them or whatever, right? And if this was something we were going to do a lot of, guess what? I could make my own version of a linked list class by extending this linked list and I could make a new class called LinkedList. But in that new class, I could make my own toString method. And since I'm extending this class, I would automatically have all of these methods. I don't have to write them myself because they're inside the thing I'm extending. But I could make my own toString, which would, convert my list to a string in some different way. So we'll talk about class extensions separately in a few weeks when we start doing GUIs. But that's another concept. And this is all basically in the general notion of reusing code, right? Being able to take something that has lots of different capabilities to it and start using it and building on top of it instead of kind of reinventing it. Alright, so we have our rectangle class. And so here again, if I construct a linked list of type rectangle, right, I can add rectangles to this. So there's 4 rectangles we'll construct, we'll add them to our list, and we'll do the same output that we did a moment ago. Alright, and there you go, linked list of rectangles. Converted to a string by simply taking my list and concatenating it, and look at how beautiful that is, right? It's got everything in there, it's inside brackets, it's got commas in between them, and each thing is printed out with the words a 5x7 rectangle, right? Why? Because there's a toString method in the rectangle class. And the linked lists toString method, when it tries to convert this list to a string, what it does is it goes through, it pulls out each element, and it uses that element's toString method, right? So this is encapsulation. This is objects. The first thing it pulls out of my list is a rectangle, and a rectangle is a class, and there's a toString method in there, either because you wrote it or because it inherited it, and so it uses that object's toString method and concatenates that to a running string, and when it's done, that's what the toString method of this linked list returns. And then when I concatenate that to my list, I get a big string that looks like this. I pass that to the print line method, and the result is this nice output that shows the contents of my linked list in some civilized way. So again, this is the essence of the struggle, right? Being able to think of classes and objects as these entities that have all these different pieces to them that we can use. And if you start getting your brain around that, then you've got most of the battle under control. But it's a struggle getting to that point sometimes. All right, so questions about this? Final no extends right. What does that mean? Oh, if you declare something to be final, it means you can't make extensions of it. Yeah, exactly. thought you meant extensions for the final exam. Yeah, so this idea of class extension is a fun one. Um, why would you not want to extend a class? So I wondered about that a while ago when I was teaching a Java class for high school. Um, there's security considerations. For example, if you can extend the string class, you can so there's rules where you can take something which is an object of um, this is going to get a little hand wavy and off track, but really briefly, if you have some object and you extend it, some class that you extend, so this is an object of type, some extension of that, you can still treat this thing as one of these things. In other words, if you have a method that expects one of these, you can hand it one of those, and it will usually still work. And so one thing I was able to do was make an extension of the string class and put some hooks in it that would take, every time that you called some method, it would take the contents of the string and send it to, a socket somewhere on a network address. And then if you had some method that was expecting a string, you could hand it one of these strings instead. And it seemed like you could use that to trick a piece of Java into running your code when it thought it was doing something like, calculating the length of a string or comparing one string to another. I could actually get it to run my own code, and if it's something like the equals method that takes two arguments, I could interrogate that second argument and do some exploits like that. So I don't know if that's part of the reason, or if it's more wholesome, where you just don't want to make variations on a class. I don't know. That would be a good thing to look up. But the only thing I could come up with was security issues. On the other hand, the reason we want to make extensions is because, we don't want to reinvent the wheel. So when we start talking about, making GUIs, for example, we will want to draw a frame that, has some appearance to it. And there's, some button up here in the upper left that we can click to get a menu, and there's an X button and a dash and a maximize, and you can grab a corner and resize your window, and there's going to be all this stuff that we want to have happen when we put up a frame on our display. We never want to write all that code ourselves, right? Or we don't want to write that code ourselves if all we're trying to do is display a tic-tac-toe board so somebody can play a game, right? But we want all that capability. But we also want this thing to display a tic-tac-toe board, and maybe do something like when you hit the X button, say, do you really want to quit? And so what we would do, instead of writing all the code for all of this stuff, is we would start with the code for a basic, what's called a frame or a J-frame. And we would say, okay, that's a good start, but I want to add some more things to it. I want to add something that shows me a tic-tac-toe board. And I want to change this other thing that happens when you click the mouse or something like that. So we started making new classes that are derived from old classes, and that's the notion of class extension. And it's one of the key ideas of object-oriented programming, is being able to take a base class and extend it and change it. Yeah, totally. And yeah, I've wondered if there's a monetary issue to the final keyword. I don't know. It's a good question. All right. This afternoon section is smaller than the morning section, and so this quarter it seems like we're going to be ahead of the morning one, because the morning one usually we spend a good chunk of it with questions in the beginning. So we'll kind of probably be a little bit ahead of the morning one, but we'll generally stay in sync from week to week. So let's go over scanners. So PA2, which I'll post this afternoon, PA2 is going to involve opening a file and reading contents from it. Um, and more generally, right, we often need to read input from a user while our program is running. Now, we know we can pick up command line arguments. We can do that, with the string bracket bracket args. Um, but runtime inputs, right, while your program is running, you want the person to type an answer to a question or type a number or something. You want to be able to pick that up. So we want to be able to do input from the user or from a file, and then following that, we're going to want to do output to a file. We can output to the screen already. And like I said, there's a lot of ways to do this. There's pages of graphs you can find that break down all the different classes related to input and output, and all the different subclasses, and raw versus cooked versus semi-cooked versus buffered versus unbuffered, and so on and so forth. Um, but Scanner, I find, is, for this course, and actually for a lot of stuff beyond this course, this is powerful enough to do most of what we want to do. If you're doing like really high speed, low level binary input, right, you probably want to go to something like, a reader or something like that. But scanners work well, and they're another good introduction to class-like ideas. Let's see, I wrote a program called House in Java. Every class extends item. There's a class called container. Fridge and bookshelf are extensions of container. Oh, cool. Yeah. I need a good example sometimes of class extensions. Everybody seems to do either shapes or cars, right? This is a vehicle, and a car is an extension of a vehicle, or this is a shape, and a rectangle is an extension of a shape, and a square is an extension of a rectangle. But there's the GitHub page. Cool. I will take a look at this, because this might be nice. And it's GPL'd. Okay, cool. I'm game. When did GPL get so long, by the way? I was looking at this the other day, because I was pushing some code out, and I was using some stuff that was GPL'd, and it's like, wow, that whole thing has gotten pretty huge. So I've been doing Creative Commons more and more for the past few years, but yeah, I think that's. I don't know if there's a default license on GitHub. That's a good question. I mean, that kind of seems to be the one that most people use, but I don't know if that's an automatic default. Yeah, so that's where I am. I don't want to really worry about the licensing, since I'm putting this stuff out there for public use anyway. If I mess up somehow, maybe people can't use it, but it's not like I'm going to miss out on my profits or something. So I do that pretty low ball. All right, let's look at scanners. So a scanner comes from java.utility, okay, just like LinkedList. And for us right now, we're just going to construct it by giving it system.in. Okay, system.in is kind of like standard in Unix. And there's a system.out, which is like standard out. Guess what? System.out.println. System.out is a class, and it has this println method. So system.in, uppercase S, is kind of like standard in. And if we construct a scanner using system.in, we can use that to read from standard in, whether that's the keyboard or redirection or something like that. And I'm going to start off with just one particular method, or two particular methods, which is has next line and has next line. So has next line tells me if there's another line of input that can be read, and the next line actually reads in that next line of input and returns it as a string. right, so let's make an input test.java. So you know, when we make a file in C, more often than not, the file pointer is called FP. I don't know why. I think it's because that's what Koenig and Ritchie did in their book. That's why I do it. So when we make a scanner, a lot of times we'll call it SC, but this is just a variable name, right? It's an object. We could call it anything we want, but you'll usually see me call it SC. So I'm going to do scanner SC equals new scanner system.in. And I'm going to say, well, SC has next line. And I'm going to call the next line method. So has next line is a Boolean. It tells me whether or not there's another line of input available. And if there is, then I'm going to come down here and I'm going to call the next line method, which says, give me the next line of input from what? From system.in, right? Returns that as a string, and I'm going to store that in temp. And I'm going to print that out inside angle brackets. And so there's my test program for playing with scanners. And I'm going to have to import Alright, so I can compile that, and if I run this, it sits there while it's waiting to read from standard in. So I can say hello, and guess what? It read, you know, temp equals hello. The backslash was a typo. Haha. I can hit empty lines. I can hit lines with spaces in them. I can hit really, 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 really long lines and not worry about buffer overruns. And when I'm done, when I want to signal end of input, I can hit a Control D as usual, and that detects that there's no next line available. So this has next line will return false, which kicked me out of my while loop, which was the end of my main method, and so I exited. And if I redirect input from a file, right, then this reads the contents of that file, and you know, that's what comes in each time I say next line. So this is a little bit like, you know, what we do with fgets in C, but totally different approach, right? Fgets is a function you call and you tell it what file you want to read from, right? And you tell it what buffer you want to read into and how many bytes are available. In this case, we construct a scanner, and when we construct the scanner, we tell it what we're going to read from. And from that point on, the scanner has this next line method that does basically fgets. It reads in from the stream that was used when we constructed the scanner, and this function returns a string, which we can do whatever we want with. And if I take out the while loop, and I just do temp equals sc.nextLine, right, that works great. It reads one line and it exits. But in the beginning here, if I hit a Control D, I get an exception. Right? Why do I get an exception? Because I called next line, but there was no next line available. Because I hit the end of my input, the end of the file, the Control D. That's an exception. So we avoid this exception by first calling has next line before we call next line. Alright, so we'll dig further into this on Friday. We'll play with this. We'll talk about blocking calls, because has next line will block. And then we'll talk about print writers for doing output. We'll talk about how to read in from files, and mostly we'll talk about PA2. So that's a bit of a head start on scanners. All right, so come to class tomorrow if you want to do lab work. Come by office hours if you like also. Have a good afternoon. I will see you next time.